Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models and running your continuous integration, they just launched dedicated CPU instances. Go to pythonpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, Corinium Global Intelligence, and Data Council. Upcoming events include the O'Reilly AI Conference, the Strata Data Conference, the combined events of the Data Architecture Summit and Graph Forum, and Data Council in Barcelona. Go to pythonpodcast.com/conferences today to learn more about these and other events, and take advantage of our partner discounts when you register. Your host as usual is Tobias Macey, and today I'm interviewing Jen Helsby and Kushal about SecureDrop, a secure platform for submitting and receiving documents anonymously. So Jen, can you start by introducing yourself?
Sure. My name is Jen Helsby, and I'm the lead developer of SecureDrop.
And Kushal, can you introduce yourself?
Hi, I'm also a maintainer of SecureDrop, and I'm part of various other projects, including as a Python code developer. And we both, Jen and me, we both are part of the Tor project also.
And Jen, do you remember how you first got introduced to Python?
Yeah, I started using Python when I was in graduate school. I did a PhD in astrophysics, and so I started using Python for data analysis. This is some years ago.
And Kushal, how about you? Do you remember how you first got introduced to Python?
Yeah, I saw Python back in college days, but in 2005, someone told me that I can try to write applications for my Nokia phones using Python. Sadly, I had a different version of Nokia, which Series 90, which never had Python. But yeah, that's how I got into it.
And so can you start by describing a bit about what the SecureDrop project is and how it got started and how you each got involved with it?
Yeah, totally. SecureDrop's an anonymous whistleblowing platform that was first created by Aaron Swartz, Kevin Paulson, and James Dolan around 2012. And that was around the time that WikiLeaks was in its heyday, and they had this submission system, and they were getting interesting documents through it. And so the idea was to create an open source project that would be something similar that major news organizations could use to also get documents while protecting the identity of sources. And so it's not really a new idea, because news organizations have had anonymous tip lines for some time, but doing it in today's kind of surveillance landscape is the challenge. And I got involved 3 years ago. I had installed SecureDrop and thought it was a great project, and so I started working on it.
I think my introduction to the project was in a different way. I saw Freedom of the Press Foundation and SecureDrop from a distance all the time. And back in 2017, I was actually wondering if I should drop an email to Freedom of the Press saying hey, if I can work on the project full time. And I was not being able to do so till the time my wife Anvisha, she actually pushed me just write to them and see what happens. And that changed many things in life. And I'm happily working on the project.
And so can you give a bit of background as to some of the wheres and whys of when the SecureDrop project is useful?
Yeah, totally. So there are a lot of people that might want to share information with a news organization, but might fear what will happen to them if they are identified as the person who shared the information. So they might be fired, or in more kind of extreme situations, they might even be potentially charged with a crime or worse. And generally, reporters, at least in the US, will refuse to provide a source's identity when asked by the government. And so the general problem is that, in today's world, all communications are mediated by third parties. And now the government doesn't need to ask a journalist who's the identity of your source. They can just go to a third party and ask them. And so we started seeing this happen a lot more during the Obama administration, where the government would get a court order to acquire the telephone records of a journalist in order to identify the source. That happened with the Associated Press, for example, under Obama, and happens even more under Trump, unfortunately. And so that's the situation where if an organization thinks they're going to get sources of that type, then using or providing SecureDrop along with other channels is a good idea.
Yeah, given the fact that a lot of the sort of original ways that journalism was done was much more face to face, it was possible to be able to shield your sources because you didn't have those electronic trails for people to be able to follow and uncover who might have released a particular document. But with the global nature of communication and the fact that a lot more people will be collaborating over larger distances, it increases the availability and access to that information, but as you said, it increases the potential risk. So it's definitely good that there are platforms such as SecureDrop available to help ensure that there is the availability of that information without necessarily putting people at risk in the process of providing it.
Yeah, absolutely. Even like meeting physically in the modern age, sometimes people are like, okay, well, I won't call them on the phone, but then I'll meet them physically. And that's still, in a city, certainly produces a significant amount of data because there's CCTV cameras everywhere, facial recognition. And that's something that, depending on the adversary you're concerned about, could be used to identify you. So yeah, it's quite a hard problem.
So for somebody who is running an instance of SecureDrop and somebody who wants to submit some information to that organization, what does the overall workflow look like for the person who is submitting, either in terms of just discovering the availability of it in the first place and then actually providing the information, and then on the receiving end, the actions required to actually retrieve that information and make use of it?
Yeah, I mean, I can talk from the source point of view, and then Jen can explain what happens in the from the journalist point of view. So generally, most of the news organizations they also publish the URL of their SecureDrop instance via other medium like their normal news website. Some physical newspapers also print it in the physical copy, and we also have a directory where we have verified URLs from different organizations who are running SecureDrop. So a source can identify from many of these cases, or one particular case we saw one organization actually put their URL in a billboard in front of another large organization. So when a source sees this and if they try to read a little bit more about how they can submit, uh, all of these websites generally also give some sort of bare minimal steps for the sources, how they can actually use Tails operating system in a go to a different network like a cafe or somewhere. Don't try to do anything from your office network, and they will open up using Tor browser on Tails. They can open up the instance and just click and log into the box and submit any documents, or they can ask any questions or send some sort of messages. And this, from the source point of view, they do not get username, password, or anything details. They just get one big diceware generated password, which they have to just remember for next time use. Jen, you want to go ahead for the journalist?
Once the source has uploaded either documents or messages to a SecureDrop server, then the journalist will come along and they will access another web application that is separate from the web application that sources are using, again using Tor browser, and they will download those documents, whatever they're interested in, and then they will transfer those documents across an air gap. So they will transfer it to a machine that has never been connected to the internet and is not currently internet connected, using some storage device like USB drives or CDs. So they take these documents across, and that is where they decrypt and read those documents on an air gap machine, which we call a secure viewing station. And so that's the only place where documents can be decrypted. So at that point, they'll either decide to respond to a source, in which case they need to go back to an online machine and send messages back to that source, who can then log in again and read them, or they will transfer those documents that they've decrypted to another workstation in the newsroom, or print them out such that they can take them to their editor or whatever their workflow is after that point. So it's kind of a bit laborious having to traverse this air gap, but the main concern that motivates that design is it's one of those scenarios where you're asking just random people on the internet to submit you files of any type, and then the journalist is going to open those files. And so the concern is what if the file contains malware? And so we want to keep that compartmented from the rest of the system.
And because of the fact that there is the potential for malware, I'm wondering what any sort of best practice or standard operating procedure is in terms of the air-gapped computer, as far as ensuring that it is up to date with its security benefit, up to date with its security updates, and has some sort of active protection to prevent any sort of malware from corrupting the rest of the machine. Or, I mean, given the fact that it's air gapped, there's less of a sort of blast radius where you don't have to worry about it escaping from there. But I'm wondering if there's any sort of potential compromise as far as other information on the machine that might get destroyed in the process of opening some of those files, or just making sure that the overall security of that system is up to date as well, given that it's not connected to the internet.
Yeah, I mean, it's one of the main challenges with an air gap is it's not going to be getting automatic security updates, and so people do need to manually update the air gap. The main concern right now with this air gap system is if an attacker can get code execution, it is the same place where the private key is stored, and so we still don't want to allow that to happen. If they do get code execution, all of the physical devices that could be used to exfil data are removed. So, for example, the network cards are removed, the mics are removed, etc. So even if you can get a foothold, it's hard to get data off the system.
Oh, I was saying, like, we also use Tails in both the journalist workstation and also the SVS, the secure viewing station. So Tails also provides some sort of like support as a like, air gap system here.
Well, it has this amnesiac property, which is why we use it. So almost everything on the system will be destroyed when you reboot it. So there's just one directory that stays, that persists, and everything else is destroyed. So that's a real advantage in the case of malware potentially getting a foothold on the secure viewing station.
And as you mentioned, some of the overall workflow, particularly on the receiving side, is a bit laborious. And then also on the person who's submitting the information, as you said, there is the potential for responding back to them, but it requires them to actively go back and log in with that randomly generated password to be able to see if there are any return messages without any way of being notified of their presence. So I'm curious if there's any sort of common workflow that people use to try and reduce any sort of latency or barrier as far as the return communication to maintain some sort of a dialogue, or if the sort of document submission can serve as the riskiest piece of business and then the rest of the communication can happen in somewhat of a more convenient form factor.
So there are people that just come to SecureDrop, dump documents, and never return. And then there are people that have these more extended interactions, like there are people that only talk through SecureDrop and have like long-running relationships with journalists. The truth is that we don't know too much about individual news organizations. So we should have said that we just write the software and then news organizations install it and operate it themselves. So we can't SSH into anybody's SecureDrop. It's all managed by administrators at each individual organization. And as a project, we don't want to know too much. I mean, we need to know some about what users are doing in order to design the system, but we don't want to know too much because it's obviously very sensitive, and that makes us a place where you could go to gather information about these common workflows and potentially use that to attack a news organization.
And also in terms of just the overall user experience, having too many sort of difficult steps or too much inconvenience in the process can often lead people to just short circuit the security and take shortcuts that will prevent the overall effectiveness of the system. And I'm wondering how you approach that user experience and education step to ensure that the overall use case and workflow of SecureDrop remains secure and sort of prevents people or encourages people not to take those shortcuts that might compromise it.
It's kind of hard for the journalist to actually use any other system than the properly set journalist workstation to access the SecureDrop instance. And the final, like, even if the journalistic workstations, if journalists can download any kind of submission, they cannot view it till they actually move it to a particular air-gapped secure viewing station. So even if they want, there is no such simple way to bypass the security. The way it is designed, it's difficult, and it becomes such a difficult level which is not easily can be bypassed to make that whole flow easy right now.
Yeah, they would need to know how to export private keys and stuff like that to circumvent the security.
And we also do trainings at those places, most of those places where they take help from us about installing SecureDrop and things. So like Freedom of the Press Foundation's, the digital security team, they not only teach about how to use SecureDrop and make it into their muscle memory, they also help to learn about digital security 101 and more details, so that the overall digital, the security hygiene, the digital hygiene is better for the journalist.
And going back to the messaging system, because of the fact that this is, at least at face value, more of a one-way relationship where somebody will submit documents to the news organization, I'm curious why you feel that the return messaging and being able to have that be a communications channel is important to the overall workflow and utility of the system.
Yeah, one of the challenges with a system like this is that the source journalist relationship is a human one. And so it can be hard to develop that rapport without having some kind of back and forth. So it might take some time before before a source is comfortable sharing something until they know that it's going to be handled properly and that they're kind of going to be safe. And so you could imagine that that's one of the uses of the messaging system. And a journalist might have follow-up questions. They might need clarification on what a document needs if it's particularly technical in nature, or they might kind of need a pointer to where they can find out more. And so that kind of back and forth is what the messaging system is most useful for.
And then also, as far as the types of submissions, I'm curious what form they generally take, whether they're PDF documents typically, or if they're sort of zip archives, just the sort of general volume and scope and sort of format support that's necessary for ensuring that you're able to access that information on the secure workstation, the air-gapped workstation, once you've retrieved it.
There is a file size limitation like 500 MB, that is like to start with. Then for as far as the file types are concerned, there is no limitation. Sources can submit any kind of document, and depending on the how the journalists want to view those documents in future, like after they decrypted it on the secure workstation, they may want to move it out to some other system, like some other fancy system maybe, which will be able to play that video or document, watch that document somehow.
Yeah, generally what we try to have good support for in terms of like opening documents is like Office kind of documents, PDFs, most common audio and video formats. That's what you can open on a Tails machine. Anything, like if you get a SQL database dump or something like that, that would need to be taken to either another machine, or the news organization would need to ferry like a deb that can open that file nicely onto the air-gapped workstation.
And then in terms of the overall system architecture, I'm wondering if you can talk through how it's designed and how it's deployed and some of the reasoning behind using Python as the implementation language.
Sure, yeah. So the way that it's architected right now is every news organization installs 2 servers. So they're both run Ubuntu server, and one server is an application server. So that hosts 2 web applications, one that's used by the sources to submit the documents as previously described, and one that's used by journalists to access documents. So that's the first server, which we're calling application server. And then the second server is a monitoring server that runs a host-based IDS that just monitors the application server and then sends alerts for potentially suspicious activity to administrators. Administrators here being the person at the news organization who's charged with keeping the SecureDrop in running order. And then we have a network firewall that separates the SecureDrop area of the network from the rest of the network in case there's a compromise of the news organization network or a compromise of the SecureDrop network, just to keep things separated. And all of that is hosted on-prem at a news organization. So it might be in their data center, or it might be, in some cases like the editor's office or the general counsel's office. And then both sources and journalists only access the application server through via Tor on in services. And that is done primarily to protect sources and make sure that they do come in through Tor. And then admins can either use Tor, or they can just use regular LAN to administer the servers. And then also a news organization needs to have a online journalist workstation that the journalist can use to download documents, and then this secure viewing station that is air-gapped as described earlier. In terms of using Python, we want to generally pick technologies that are widely used and established and easy to maintain, and we really do get an advantage of using Python. So we use that for the 2 web applications and for a CLI that administrators use to administer the system.
And given that the organizations that are running these instances don't necessarily have a lot of technical staff, particularly in the case of independent news organizations that might be fairly small. I'm wondering how you approach the overall system design to reduce the maintenance burden on those organizations and ensure that they're able to keep it up to date and appropriately secure so that it fulfills its original intent.
So, like what the actual administrators see is one or two single, basically a couple of small commands, and like as Jen mentioned, those are written in Python. But what those commands actually do is that they fire up a set of Ansible playbooks, and those playbooks make sure that the servers are in the correct state, like the IP table rules, the like what all softwares to be installed, what kind of kernel it should run. So all details for all of those servers are exactly the same, and that we can only achieve via using these Ansible runs. And that also helps to make sure that even if the administrator doesn't know much about Linux systems, they can just type this one single command, which will make sure that the servers are in the latest good shape, the way it should be.
And as far as the overall security protocols and technologies that you're using, what are some of the main factors that you're considering as you develop the project, and any weak points or edge cases that you are aware of and that you try to guard against that it could potentially lead to a compromise?
Yeah, so generally, as I said earlier, we try to use widely used and established tools. So, for example, if we add a dependency, we want to make sure that it's very commonly used. And we will, when we make an update to that dependency, we'll review the changes. So, we do things like that. In terms of just general architecting for the project, we do threat modeling to analyze the functionality, the potential threats. And then when we're deciding what mitigations to apply, we go back to our threat model. So we have a document that's internal that contains every potential threat to the system. And then we try to rank all those threats to determine how to allocate engineering efforts such that we don't spend time mitigating threats that are either low impact or very hard to actually execute as an adversary. In terms of weak points and edge cases, probably the biggest challenge right now is just there are limits to what any technical tool can do. So there's cases where sources can be identified, and unfortunately we have seen this, not necessarily people that use SecureDrop, but people that try to share information with news organizations. Operational security failures, if you're using a tool like SecureDrop and then you also email a news organization, direct those kind of situation, or if you're in a organization as a leaker and you're sharing a document that only a few people have access to, and access to the document is logged, that's another really challenging problem that we can't really engineer around. And so those are the biggest threats that face potential sources right now. And I think, certain organizations realize that just having really good logging and alerting internally can potentially mean that as soon as somebody plugs in a USB drive, you can flag it. So that is probably the biggest issue.
And as far as the overall development of the platform, what have been some of the most interesting or unexpected or challenging aspects in your experience of working on it and maintaining it and interacting with users?
Is this for the development or like use cases or things we found interesting?
Yeah, so for now, it's mainly just focusing on the actual development and maintenance of the project, and then we'll talk about some of the interesting use cases after.
I think for me, like what I always find really challenging is that we are trying to secure systems where we do not have any access. Like all these SecureDrop instances, servers, they're running inside the organizations who are running them. And we as developers, have zero access to those. So somehow we have to make sure that those systems get updated and stays as secure as they should be. That's one of the biggest one in my mind. Yeah, Jen.
Yeah, that's an ongoing challenge, especially because we're supporting, like we have contracts with some news organizations to help support the instance. And then another issue is just designing a system while trying to intentionally not know too much about how it is used. That's kind of an ongoing issue.
And as far as any sort of interesting or unexpected uses of SecureDrop or notable cases where it has proven beneficial, I'm wondering if there are any stories that you can share on that front.
There's a recent case where it was announced at DEF CON beginning of this month, that apparently the US federal government is going to use SecureDrop in order to get security vulnerabilities. So the reason why they want to use SecureDrop in that case is potential security researchers are concerned about retribution. And so if they could submit through SecureDrop, they could make sure that whatever agency is aware of the vulnerability and fix it without them being identified.
And there is the other story, which is about like someone wrote an anti-diversity memo at Google, and it got leaked multiple times, multiple versions via SecureDrop to the different organizations, which was a big news all across.
Yeah, that one definitely took a while for people to get around it, and there was a lot of conversation and consternation on all sides of that conversation. And then, in terms of the overall sustainability of the platform and the project, how do you approach any sort of required funding and making sure that you have an appropriate level of staffing on the development side? And then also the overall process for user feedback to ensure that you're incorporating new features or system improvements that make sure that everybody who's using SecureDrop are getting the benefit that they want.
Yeah, totally. So in terms of sustainability of the project, SecureDrop has been really fortunate that the project is supported by Freedom of the Press Foundation. So Kushal and I are both employed by Freedom of the Press Foundation. They took the project over after Aaron Swartz unfortunately passed away, I believe in 2012. And so FPF, which is short for Freedom of the Press Foundation, has supported development for several years since then. We've also been fortunate to get funding from Mozilla Open Source Support, which supports a bunch of internet freedom projects like Tor as well. And so thanks to their support and other kind of grant-based funding and small donors that donate to FPF, we've been able to keep the project maintained. In terms of user feedback, we get user feedback either through just our bug tracker like other projects. We have like a private support portal that organizations that install SecureDrop can use to file tickets if there's an issue or if there's something that they want changed. And then we also do surveys and user testing, and we do reach out privately to existing users of SecureDrop to do that.
Since SecureDrop is a platform that provides a means for circumventing surveillance, I'm wondering if there have been any cases where you've had to deal with any sort of pushback from either governments or other organizations that are either trying to shut the project down or have some sort of influence over it.
Not that I know about anything.
Yeah, I'm not aware of anything like that either. I mean, I think we have, at least we both started working on the project when it had already kind of become pretty mainstreamed, and a lot of big news organizations like New York Times, etc., were using it. And so I think it would be pretty controversial if, a government agency were to kind of publicly go after SecureDrop, the project at this stage.
And then in terms of the overall system maintenance, you mentioned that you have the Ansible playbooks that allow users to get it deployed. I'm curious how you publicize to the different agencies that there's a new release available and how you simplify the update process to ensure that they're running the latest versions, particularly if you have any dependencies that have some sort of CVE or vulnerability that's present on the system to ensure that they stay up to date. And then particularly for long running instances, how you help them with any sort of system upgrades of the underlying operating system.
So, like all SecureDrop servers by default, they get any security updates that comes out from the Ubuntu as an operating system. And then we also if there is any changes from us or new version or new bug fix version, those will also get pulled into the servers and deployed without any intervention from the system administrators. So, and those servers regularly get rebooted every day based on the time the sysadmins decided. And so that and we do a lot of QA on those updates to make sure that those updates can pull in any other actual security updates or any other kind of dependencies which required to be there. And as far as the operating system updates, and we did one recently, we moved out of Trusty into Xenial Ubuntu, and for that we actually worked a lot on the messaging and making sure the administrators get the proper steps and help documents and everything, so that they can go through the certain steps to make sure that the transition happens without any hiccups. So all of those things together helps the systems to be updated.
And then also, as far as testing and verification, I'm wondering what that QA process looks like to ensure that you're not introducing bugs or potential regressions or security vulnerabilities into the platform as you're preparing a release.
SecureDrop is a free software project, and the source code, the bug trackers, and everything is public. And you can, like, actually anyone wants to go and check, they will find the issues filed for each of the release, where we have a huge amount of like QA steps, like each and every parts of the project we manually verify. And then as far as, like, if you ask me as a developer, this is one of the best tested project as I have seen in my life, as far as that, like, integration test cases, the kind of unit test cases we have in the project. And like, for any kind of feature to go in, it actually gets verified by multiple reviewers, and then all, like, we all, like, continuously running and executing those scripts and, like, the actual server, to make sure that the server behaves the way it should. And we have like 2 weeks of
Yeah, before every release. No, I was going to say the exact same thing, that we do a freeze 2 weeks before a release. In order to test everything and make sure that, even though every new feature has test coverage, we still want to test things manually because some parts of the architecture are difficult to have automated tests for. So we have like tests for the web application, we have tests for the system state using test infra. But for example, the full workflow of installing from Tails the 2 servers, that's not fully tested. And so we do that each regular release.
and multiple times.
As far as your overall experience for each of you individually on the project, what have been some of the most interesting or unexpected or useful lessons that you've learned in the process?
Like, I think Jen also already mentioned, one of the things is that supporting any project where we do not have any kind of access, that was kind of difficult. And like, building a system which will be used by people who are not always so much into Linux, or like friendly to the our in sense, like the developers way of life. So like, building any system for users, keeping those users in mind, is always a challenge.
I guess for me, like making sure, for any system that has a large number of potential threats, making sure that time is being spent on the kind of lowest hanging fruit in a more rigorous way, like we've done with the threat modeling process I described earlier, is so valuable, because it's kind of like security nerds. Sometimes we want to focus on like the most interesting attacks that we can think of, and it can be tempting to get drawn into those. But kind of having a more rigorous approach to, okay, the easiest thing that an attacker could do is X. Like, let's make sure that we reduce the risk of this and come up with a mitigation is really valuable. And I haven't really seen too many projects of this type publicly present that information, kind of how they went about the threat modeling process. It would be cool to see that. We've shared some of our threat modeling documentation in our public docs at docs.securedrop.org.
And as far as any particular packages or libraries that have been most useful in the process of building SecureDrop, I'm wondering if there are any that are notable that you'd like to call out.
The web application is Flask, and we also already mentioned Ansible. That's another application, like huge application, and we use Molecule for our test and test infra for testing part. And then a Tor project is obviously the one of the biggest thing of the whole project. Tor and Tails. Jen?
Yeah, for security automation, a project that we use, which is really great, is Bandit, to do static analysis, which we run in CI, Bandit and safety, so that we can get we can fail CI when a CVE is found in one of our dependencies, and if other issues are introduced in a PR, it just reduces the amount of manual review. It's really great to easy to integrate, and probably useful for any project, not just one that's security sensitive.
In terms of the future of the project, what are some of the new features or improvements or just overall work and effort that you have in store in the near to medium term, and any help that you are looking for from the community to improve it or add new capabilities?
Sure. So I guess one of the challenges right now is that we've made it pretty easy for sources to share documents with journalists. They just need to download Tor browser and go to a website, basically. But a lot of that complexity has been offloaded to the journalist side, as it's described earlier with this kind of clunky workflow. And so one of the things we've been working on is making it easier for journalists to check SecureDrop, so that instead of it taking maybe 30 minutes, it maybe could only take 5 minutes. And so we've been working on a project for journalists, a workstation that combines the currently 2 separate workstations. So right now we have this online workstation that's connected to the internet that they use to download the documents. And then we have a separate workstation that's air-gapped that they use to read the documents. And so we've been experimenting using Cubes, which is a great project, and you should all check it out, which is basically a Zen distribution where everything is running inside a VM. And so they also have this concept called disposable VMs, which is kind of perfect for a SecureDrop because it's the kind of situation where you could open a potentially malicious submission in this disposable VM. If it gets popped, it's fine. It's compartmentalized in the VM. Modulo Zen escapes, and then it's destroyed after use. And so we've been experimenting kind of architecting a kind of inter-VM pipeline that would download documents, pass them to a VM that's running a nice GUI for the user, and then when the user clicks a button, open document, it opens in this disposable VM. So that's all the code for that is public on our GitHub org, Freedom of Press. And so if you're interested in helping out, probably the easiest place for people to get involved would be this GUI that I described, which is written in Python. It's cute, and there's a lot of active development on that right now.
Are there any other aspects of the SecureDrop project or the use cases that it enables that we didn't discuss yet that you'd like to cover before we close out the show?
I don't think so. But if you are maybe interested in learning about the organizations that if you have information you would want to share, you should download Tor browser and then go to securedrop.org/directory to get a list of many of them.
All right. Well, for anybody who wants to get in touch with either of you or follow along with the work that you're doing, I'll have you each add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week I'm going to choose laser tag because I got to hang out with my kids yesterday and some of their friends and our friends, and we all had a lot of fun playing laser tag together. So it's not something I've really done in the past, but turned out to be quite enjoyable. So if you're looking for something to get up and move around and have fun doing it, it's worth taking a look at that. And with that, I'll pass it to you, Kushal. Do you have any picks this week?
Oh, I'm actually waiting for, not for this week, but within few weeks, like Edward Snowden's book is coming out, so I'm just waiting for that.
All right. And Jen, do you have any picks this week?
Do I have any picks? I'm racking my brain. I don't know that I do, but I will definitely check out Edward Snowden's book, released September 17th.
All right. Well, thank you both for taking the time today to join me and discuss your work on SecureDrop. It's definitely an interesting project and an interesting problem space, so I appreciate your efforts on that, and I hope you each enjoy the rest of your day.
Thank you.
Thanks, Tobias.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.